Hey everyone, welcome back. In today's video, we are diving into a key concept in memory management, the stack. If you are programming in C++ or any other language, understanding the stack is essential. So let's walk through it step by step. First off, what exactly is the stack? Well, think of the stack as a special region of memory that your program uses to store data temporarily. It's called a stack because it behaves like a real-life stack of plates. You always add plates on top and you always remove plates from the top. This is known as last in, first out, or LIFO. When you run a C++ program, the operating system gives it a certain amount of memory. Part of that memory is reserved for the stack. It's managed automatically. You don't have to allocate or free memory manually for most stack operations. Let's look at an example. Suppose we have a simple function. When greet is called, two things happen. First, a stack frame is created for this function. A stack frame contains all the function's local variables. In this case, number and message are both stored in the stack frame. As soon as greet finishes running, its stack frame is popped off the stack, and all the memory used by number and message is automatically reclaimed. You don't need to manually delete anything. That's the beauty of the stack. It's fast and self-cleaning. Now, let's get a bit deeper. Each time you call a function, a new stack frame is pushed onto the stack. Each frame holds not just local variables, but also information like the return address. Basically, where the program should jump back after the function is done. So, if you have nested function calls like this, when function A calls function B, a stack frame for function B is placed on top of function A's stack frame. When function B finishes, its frame is popped, and control returns to function A. But what happens if the stack gets too big? That's called a stack overflow. It usually happens when you have deep or infinite recursion. For example, every time infinite recursion calls itself, a new stack frame is added. Eventually, you run out of memory and the program crashes with a stack overflow. Now, you might be wondering, what can you put on the stack? Typically small, short-lived data. Primitive types like int, char, float are perfect for the stack. Small structures or simple objects can also go on the stack. But large objects like huge arrays or complex data structures are better placed on the heap, another area of memory, because the stack has limited space. In C++, if you write this, the variable x is stored on the stack. But if you do this, here the pointer p itself is on the stack, but the integer it points to is on the heap. You have to manually delete heap memory to avoid leaks. But stack memory is automatically managed. Finally, why do we care about the stack? Because it's extremely fast. Allocating memory on the stack is basically just moving the stack pointer down, and deallocating is moving it back up. No complicated bookkeeping, no fragmentation. That's why many critical, performance-sensitive parts of programs use stack allocation as much as possible. However, you must be careful. Don't return pointers or references to local stack variables. They will be invalid once the function exits, like this. Here, temp will be destroyed when bad function returns. The pointer you get will point to garbage memory. Always remember, stack memory is temporary. Alright, that's a basic but solid overview of stack in memory management. Thanks for tuning in, and I will see you in the next video.